What is the derivative of sine of any variable? It is cos. So therefore, cos of tan inverse e power minus 6. So be very careful when you have composite function. You have to use the chain rule one by one. So that is one derivative of the function. After that, again one more derivative of the other function. So using the same concept here, in the place of x you have log x here. So 1 minus sine square x becomes 1 minus sine square log x. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we have learnt very simple derivatives of certain function in our previous session. In this session, we are going to study about 2-mark question which are all very important for your examinations also. Find the derivative of the function sine of ax plus b cos of cx plus d with respect to x. So let me take here y is equal to sine of ax plus b divided by cos of cx plus d. So the function is in the form of u by v. So let us apply the quotient rule here. So dy by dx is equal to, so first function into derivative of the second, that is cos of cx plus d. So when you derive cos of cx plus d, it becomes minus sine of cx plus d, and again differentiating cx plus d, we will get the constant c, because derivative of x is 1 and derivative of d only constant is 0. Again we get here minus second function, that is cos of cx plus d into derivative of first, and when you derive sine ax plus b, it becomes cos ax plus b into a whole divided by cos square cx plus d using the quotient rule here. So now this is sine ax plus b sine cx plus d. Outside we have minus, so minus c sine ax plus b sine cx plus d, and here we have a constant a minus a cos of ax plus b cos of cx plus d whole divided by cos square cx plus d. So this is the derivative of the given function. So if you want to take minus, you can keep it outside and make both positive. Next question, differentiate x to the power sin x, x greater than 0 with respect to x. So we have function in the form of an exponential form. So whenever we have a function like this, I already told you to use log functions on both sides. So let me take here y is equal to x to the power sin x. So this is one of the application of log x where we can simplify easily. So apply log on both sides. Apply log on both sides. So then this becomes log y, and here we know that log x to the power y can be written as y log x. So therefore here we can write here sin x into log x. Now let us derive on both sides. So what is differentiation of log y? It is 1 by y. Since you are deriving y, you have to write down dy by dx. So when you are going to derive a function containing y, derive it and write dy by dx again. So now here we have two functions. One is sine function and one more is log function. Let us use the product rule. uv whole dash is first function derivative of second plus second function derivative of first. So here it becomes first function derivative of second is 1 by x, that is log x is 1 by x, plus second function is log x and its derivative is cos x, sin x. So sin x derivative is cos x. So now let us shift here. We get dy by dx is equal to y into, here it becomes sin x by x, and here it becomes plus log x into cos x. So you can replace back what is y we have taken. So y we have taken as x power sin x. So y can be written as x power sin x by x plus log x into cos x. So this is the derivative of the given function. Next, differentiate the function sine of tan inverse e to the power minus x with respect to x. So be very careful, we have many functions here. It's an example for composite function. So use the chain rule to solve it. So let me take y is equal to sine of tan inverse of e power minus x. Remember, derivative of tan inverse x is 1 over 1 plus x square. So in the place of x here, you have e power minus x. So you have to replace the place of x with e power minus x there. So first derive sine dy by dx. What is the derivative of sine of any variable? It is cos. So therefore, cos of tan inverse e power minus x. Now derive tan inverse e power minus x. So here d by dx of tan inverse e power minus x. So here we get cos of tan inverse e power minus x into. So what is derivative of tan inverse? It is 1 by 1 plus x square. So you have to write it in the form of 1 divided by 1 plus e power minus x square. Because in the place of x, you have to replace e power minus x. But again, e power minus x is again a one more function. So derive it. D by dx of e power minus x. So now this becomes here cos of tan inverse e power minus x whole divided by 1 plus, when you multiply this becomes e power minus 2x into. What is derivative of e power x? It is e power x only. But instead of x here we have minus x. What is derivative of minus x? It is minus 1. So therefore, when you rewrite this, this becomes minus e power minus x into cos of tan inverse e power minus x whole divided by 1 plus e power minus 2x. So this is the derivative of the given function. So be very careful when you have composite function. You have to use the chain rule one by one. So that is one derivative of the function. After that, again one more derivative of the other function. So next question. If x is equal to 2at square, y is equal to at power 4, find dy by dx. So here we have a parametric function. So let me take dx by dt, because the parameter here is t. Whenever the parameter is t, derive with respect to dt. Whenever parameter is theta, its derivative will be with d theta. So now 2a is constant and derivative of t square will become 2t. So therefore, what is dx by dt? It is 4at. Now, y is equal to at to the power 4 here. So therefore, dy by dt is equal to a into 4t cube. Because when you have x power 4, it is 4x cube. Similarly, when you have t power 4, it will be 4t cube. So therefore, what is dy by dt here? So dy by dt here, it becomes 4a t cube. Now let us find out dy by dx. So dy by dx is equal to dy by dt whole divided by dx by dt. So dy by dt is 4a t cube and dx by dt is 4at. So 4a get cancelled, 1t get cancelled. So the answer will be t square. So this is the derivative. Next question. If xy is equal to e power x minus y, prove that dy by dx is equal to y into x minus 1 divided by x into y plus 1. So we have here x into y and one more exponential function. So whenever exponential functions are given, you can use log on both sides. So when you apply log on both sides, so here you can use two rules. When you apply log for xy, this can be written as log x plus log y. And similarly, anything in the form of log x power y can be written as y into log x. So now let me apply log on both sides. So when you apply log on both sides, it becomes log xy is equal to log e to the power x minus y. I already told you whenever you have log and exponential function, the value will be only x. So log e power x is x or e power log x will become x. So here this can be written as log x plus log y is equal to x minus y. So when you have log and exponential, only write the term given here. So now let us derive it. What is the derivative of log x? 1 by x. What is the derivative of log y? 1 by y. But you have to write dy by dx. Now, what is the derivative of x? 1. What is the derivative of y? dy by dx. Now, interchange here. So shift dy by dx here, 1 by x there. So then you can take dy by dx as common factor. When you take dy by dx as common factor, here you get 1 by y, and when it comes here, it becomes plus 1. And here you have 1 minus 1 by x, which can be written as x minus 1 by x. And here you have dy by dx as 1 plus y by y is equal to x minus 1 by x. So therefore, I can write dy by dx as y into x minus 1 divided by x into 1 plus y. So here, which is one and the same, we have proved y into x minus 1 divided by x into 1 plus y plus 1 is one and the same. So the next function, if y is equal to cos x, cos 2x, cos 3x, find dy by dx. Same, apply log on both sides. So when you have multiple function, log helps you to derive it separately. As in the previous case, we have written xy in the form of log x plus log y. Similarly, you can also write here in the form of log. So this becomes log y. So log of three functions here we have, we can separately write it as log of cos x plus log of cos 2x plus log of cos 3x. So that is when you have three functions, log x, y, z, this can be written as log x plus log y plus log z. Similarly, I have written here, let us derive it. This becomes 1 by y into dy by dx. And here it is 1 by cos x, because log x is 1 by x. So log of cos x is 1 by cos x and derivative of cos x is minus sin x. Apply the chain rule. Here also it becomes 1 by cos 2x and derivative of cos 2x is minus sin 2x. Again 2x is a function, so therefore it is 2. And here we have log of cos 3x. So this becomes 1 by cos 3x. Derivative of cos 3x is minus sin 3x. And derivative of 3x is 3. So now here, dy by dx, I can shift y there. So here we have minus. So we can take minus outside. Sin x by cos x, tan x. I have taken minus outside. So here I have plus 2. Sin 2x by cos 2x can be written as tan 2x. Next, I have taken minus outside. I have 3 there. Sin 3x by cos 3x can be written as tan 3x. So, replace the value of y here. So, therefore, dy by dx is equal to minus, what is y we have taken? Cos x, cos 2x, cos 3x into, So here we have tan x plus 2 tan 2x plus 3 tan 3x. So this is the derivative of the given function. Next question. If root x plus root y is equal to root 10, prove that dy by dx is equal to minus root of y by x. So we know the derivative of root x is 1 by 2 root x. So this is an example for implicit function. Derive both x and y simultaneously. And root y will be 1 by 2 root y. Since you are differentiating y, you have to write dy by dx. And derivative of root 10, which is purely constant, 0. So now we can write here 1 divided by 2 root y dy by dx is equal to, when you shift that side, it becomes minus 1 over 2 root x. We can cancel 2 here. So we can write dy by dx. So we have minus root y can be shifted in the numerator. So this becomes root y by root x. So therefore, dy by dx can be written as minus root of y by x. Hence we prove. Next, if x square plus xy plus y square is equal to 100, find dy by dx. So let us derive it. X square is 2x. X into y is a product here. So let us apply the product rule. First function into derivative of second plus second function into derivative of first. Done. Now y square becomes 2y into dy by dx and derivative of constant is 0 here. So now here we have 2x and plus y separately. Take dy by dx as a common factor. So when you take dy by dx as a common factor, here it becomes x plus 2y is equal to 0. Shift the function towards that side. So we can write dy by dx x plus 2y is equal to, we can take minus of 2x plus y. So therefore, dy by dx can be written as minus 2x plus y divided by x plus 2y. So when you shift both that side, both becomes negative. That's why you can take minus as a common factor. So it remains positive. Next, shift to the denominator. So this is what dy by dx. So the next question, if y is equal to sine of log base e to x, prove that dy by dx is equal to root of 1 minus y square divided by x. So dy by dx, we have sine of log x will become cos of log x. And what is the derivative of log x? 1 by x. So here dy by dx is equal to cos of log x divided by x. But I have to find dy by dx in the form of root of 1 minus y square. We know that sine square x plus cos square x is equal to 1. So cos square x can be written as 1 minus sine square x. So that is here cos x can be written as root of 1 minus sine square x. So using that result here, cos of log x can be written as 1 minus sine square log x under the square root divided by x here. So using the same concept here, in the place of x you have log x here. So 1 minus sine square x becomes 1 minus sine square log x. But what is this sine square log x? Here sine of log x is nothing but y. So therefore this becomes, in the place of sine of log x, if you replace y, it becomes 1 minus y square divided by x, and hence we have dy by dx as required. Next question, find dy by dx if ax plus by square is equal to cos y. So we have ax plus by square is equal to cos y. Write the given function, derive it. So a is constant, derivative of x is 1. So 1 into a is same. B is constant. Derivative of y square is 2y into dy by dx. Derivative of cos y is minus sin y into dy by dx. So shift a that side and minus sin y dy by dx this side. Take dy by dx as a common factor. So then that becomes 2by plus sin y is equal to a, and which becomes minus a when it moves to the right hand side. So therefore dy by dx is equal to minus a divided by 2by plus sin y. So this is the derivative. Find dy by dx if sin square x plus cos square y is equal to 1. So sin square we have, first whenever you have any polynomial function, first convert it in, first derive it, then you apply the trigonometric function later. So when you have powers, first derive the powers and later on the given functions. So let us derive sin square x. Sin square becomes, so if you have x square, you will write it as 2x. So when you have sin square, you can write it as 2 sin x. Now derive sin x. What is derivative of sin x? It is cos x. Similarly, you have cos square y. So when you have cos square y, write it as 2 cos y. And derive cos y, it becomes minus sin y into dy by dx, which is equal to 0 because derivative of 1 is 0. So now you have 2 sin x cos y minus 2 sin y cos y dy by dx is equal to 0. So using the multiple angle formula, 2 sin theta cos theta is nothing but sin 2 theta. So therefore here it becomes sin 2x minus sin 2y into dy by dx is equal to 0. Or when you replace it back, you get dy by dx is equal to sin 2x divided by sin 2y. So when you move this and dy by dx becomes sin 2x divided by sin 2y. So this is the derivative of the given function. Next, find dy by dx if y is equal to e power x divided by sin x. So clearly both are a single function and you can apply the quotient rule here. So we have here dy by dx is equal to, so this is in the form of uv whole dash. So we have here u, that is e power x, derivative of sin x is cos x, minus sin x as it is. Next, derivative of e power x is e power x only, whole divided by sin square x. So using this rule, that is uv dash minus vu dash divided by v square, quotient rule. So we can take e power x as a common factor. So we get here cos x minus sin x whole divided by sin square x. So this is the derivative of the given function. So I hope you are able to understand how we are going to derive a special type of functions here also. So in this session, we have learnt a 2 marks question. We'll meet you with the 3 marks questions in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.